Computer networks have revolutionized the way we live, work, and interact with the world. From the internet to mobile phone networks, computer networks enable us to communicate and share information with lightning speed. But how do these networks actually work? What are the underlying principles that allow computers to connect and communicate with each other? At its core, computer communication involves the transmission of data between two or more devices. This data can be anything from a simple text message to a complex multimedia file. To facilitate this communication, computers use a set of rules called protocols, which ensure that the data is transmitted and received correctly. Networking takes this concept a step further by connecting multiple computers together, allowing them to share resources and communicate with each other. These networks can range in size from small home networks to vast global networks like the internet. Understanding the basics of computer communication and networking is essential for anyone who uses technology today. In the following sections, we will delve deeper into the different aspects of computer networks, from the physical connections to the different types of networks that exist. Computers communicate with each other by sending and receiving data. This data is transmitted in the form of digital signals, which are essentially a series of zeros and ones. These signals can be sent over various physical media, such as copper wires, fiber optic cables, or wireless radio waves. To ensure that the data is transmitted correctly, computers use a layered approach to communication. Each layer in this hierarchy performs a specific function, and the layers work together to ensure reliable data transmission. For example, the physical layer is responsible for transmitting the raw data bits over the physical medium, while the network layer is responsible for routing the data packets to their destination. One of the key benefits of networking is the ability to share resources. For example, in a home network, multiple computers can share a single internet connection. This allows everyone in the household to access the internet without needing their own dedicated connection. Collaboration is another important aspect of computer networking. By connecting computers together, we can work on projects together, share files, and communicate with each other in real time. This has led to the rise of collaborative tools such as Google Docs and Slack, which have transformed the way we work. Point-to-point connections are the simplest type of network connection. As the name suggests, they involve a direct connection between two devices. This type of connection is often used for short-range communication, such as connecting a printer to a computer. One of the main advantages of point-to-point connections is their simplicity. They are easy to set up and configure, and there is no need for complex networking equipment. Additionally, point-to-point connections offer high bandwidth and low latency, as the data is transmitted directly between the two devices without any intermediaries. However, point-to-point connections also have some limitations. They are not scalable, as each device requires its own dedicated connection. Additionally, if the connection between the two devices fails, the communication is disrupted. Despite these limitations, point-to-point connections remain a valuable tool for short-range communication, particularly in situations where simplicity and performance are paramount. Section 4. Multiple point connections, sharing resources. Multiple point connections, also known as multi-drop or shared connections, involve connecting multiple devices over a shared medium. This type of connection is commonly used in local area networks or LANs, where multiple computers need to communicate with each other and share resources. One of the main advantages of multiple point connections is their cost effectiveness. By sharing a single medium, multiple devices can connect to the network without needing their own dedicated connections. This makes multiple point connections an attractive option for businesses and organizations looking to build affordable networks. However, multiple point connections also have some drawbacks. One of the main challenges is contention, which occurs when multiple devices try to transmit data over the shared medium simultaneously. This can lead to collisions, which can slow down the network and cause data loss. To address this challenge, various media access control or MAC protocols have been developed. These protocols define rules for how devices can share the medium and avoid collisions. Some common MAC protocols include carrier sense, multiple access with collision detection or CSMACD, and token passing. Section 5. Tree topology, a hierarchical structure. Network topology refers to the arrangement of nodes and connections in a network. There are several different network topologies, each with its own advantages and disadvantages. The tree topology is a hierarchical structure that resembles an upside-down tree. At the top of the hierarchy is a central node called the root node, which is connected to multiple branches. Each branch then connects to other nodes, forming a hierarchical structure. One of the main advantages of the tree topology is its scalability. New branches can be easily added to the network without disrupting the existing structure. Additionally, the tree topology is relatively easy to manage, as each branch can be treated as a separate network segment. However, the tree topology also has some drawbacks. One of the main disadvantages is that the entire network can be brought down if the root node fails. Additionally, the tree topology can be prone to congestion, as all traffic must pass through the root node. Despite these limitations, the tree topology is a popular choice for large networks, particularly those with a hierarchical organizational structure.